Okay, so now we're going to talk about another special case. I'm just going to show you something really quickly. So I'm going to multiply this binomial and trinomial. Things I noticed, 3x squared is equal to 9x squared, and 4 squared is 16, and 12 is 2 times that. But I'm just going to go through and multiply this. I think the easiest way to multiply these. So I have 3x plus 4, and then I have 9x squared minus 12x, and I have 16. If I multiply this out, I end up with 27x cubed. Okay, 36x squared, negative 36x squared, negative 48x, positive 48x, and 64. Okay. Things to notice, these two add to be 0, these two add to be 0. So your final answer is going to be 27x cubed plus 64. This is called the sum of cubes. Okay, because they're both perfect cubes. Okay, because 3 times 3 times 3 is 27, and 4 times 4 times 4 is 64. So this right here, the cubed root, and this is the cubed root, which we don't need to do too much. And the cubed root of 27x cubed is going to be 3x, and the cubed root of 64 is 4. I'm going to talk a little bit about cube roots, but not too much because I don't want to get into it too much. But cubed roots are like square roots, except a number has to go into it 3 times versus 2 times. So instead of looking for pairs of numbers, you're going to be looking for 3 numbers. So again, 27. So the cubed root of 27, well, that 27 is 3 times 3 times 3. There are 3 3's that are in 27, so the cubed root of 27 is 3. 64 is 4 times 4 times 4. Okay, and so that's why the cubed root of 64 is 4, because there are 3 of the same number that goes into that. I'm going to do this one really quickly. 2x minus 3, 4x squared, 6x, and 9. That's going to be 8x cubed minus 12x squared, 12x squared, minus 18x, positive 18x, and minus 27. These add to be 0, these add to be 0, and so my final answer is going to be 8x cubed minus 27. Now, I talked about cubed roots. The cubed root of 8x cubed, okay? Well, 8x cubed, if we actually go through our whole simplification process, is 2 times 2 times 2 times 3 times 3 times 3. So the cubed root of x cubed, instead of looking for pairs, you're looking for, instead of having a date, it's going to be a group of 3, so you take that out. So the cubed root of 2 cubed, or 8 is 2, and the cubed root of x cubed is just going to be x. And the same thing goes for 27. Now we can break down 27. 27 is actually, 27 divided by 3 is 9, 9 divided by 3 is 3, 3 divided by 3 is 1, and so 27 is the cubed root of, so the cubed root of 27, excuse me, is the cubed root of 3 times 3 times 3. And since there are 3 3's there, this would just be 3. So first thing I want to talk about are my perfect cubes. 1 cubed, so 1 cubed is 1, 2 cubed is 8, 3 cubed is 27. So these are probably ones that you're not as familiar with. 4 cubed, because you don't have much of an experience, is 64. But you might want to use this as a cheat sheet. 5 cubed is 125. 6 cubed is 216. 7 cubed is 343. 8 cubed is 512. 9 cubed is 729. And we'll go to 10 cubed, which of course is 1,000. So the sum of cubes has a basic rule. It's kind of hard to kind of explain as far as going through and exactly how it works, but basically if you're given your terms, a perfect cubed and a perfect cubed, I'll show you. But first thing you always do as you do anything is you always have to find the GCF. After you find the GCF, what you're going to do is something very similar. So you have a cubed plus b cubed. You find the cubed root of each part, okay? And they come out pretty nice. And then you're going to take those values and you're going to put them into this formula. So it's going to be a plus b, whatever your a value is, plus whatever your b value is when you take the cube root, times your a value squared minus 2 times your a value times your b value plus your b value squared. And actually you can see that in the works up here, okay? So I'm going to write my rule again. It is a plus b times a squared minus 2ab plus b squared. So no GCF. So for the first one, there's no GCF. Okay, so I do the same thing I did for my difference of squares. I find my first term, so the cubed root of x cubed is just going to be plain old x because there's 3 x's. Okay, and then b is going to be the cubed root of 27, which is just going to be 3. So there's no simplification. It either is a perfect cubed or is not a perfect cubed. And so what you do is you just divide the exponent by 3 essentially if you have a variable there. So I know a is x and b is 3. And so I put it in the formula. It is a plus b. So I'm going to have x plus 3 times my a value squared minus 2 times my a value times my b value plus my b value squared. And I'll put all this in parentheses because I want to remind you of something. So and then you just simplify from here after using the formula. So it's going to be x plus 3. X squared is just x squared. Negative 2 times 3, I can multiply those, is going to be negative 6x plus 9. And there's my final answer. The next one, I look at it, there's no GCF. If you're not familiar with your perfect cubes, you can see up here that 216 is a perfect cube. So I look for my a term, it's going to be the cubed root of m cubed, which is m. And my b term, to use my formula, is going to be the cubed root of 216n cubed, which is 6n. So it's going to be, it's a plus b, so it's m plus 6n. Now always put parentheses around this because I'm gonna remind you, so this is going to be m squared minus 2 times m times 6n plus 6n squared. Now this is the part that you need to remember, because this is the part that students mess up the most with this, is square both parts. Because it's the whole thing squared. So that's where you have to be careful. And I'll show you exactly what I mean. So when I finish this out, this is going to be m plus 6n. M squared is just m squared. I multiply my two numbers out. So negative 2 times 6 is negative 12. mn, and when you think about putting your variables in, I always do it in alphabetical order. Plus, that's not 6n squared. That's actually going to be, remember that 6 squared is 36. That's going to be 36n squared. Okay, so square the 6 too. Square both parts. All right, that's what students mess up. And so this is your final answer. And so it's just a matter of using the formula. This next one, I do have a GCF. Okay, I do have a greatest common factor of 2. I don't know why this is doing goofy things. I have a greatest common factor of 4, excuse me. Okay, so I divide each part by 4. So I end up with, I divide the 5, so I take my 4, I put it on the outside. 500 divided by 4 is 125. A cubed plus, and then 4 goes into 4 once. Okay, I then stay over here. I find my a value, and my a value is going to be the cubed root of 125 a cubed, and you can use your little cheat sheet up there. It's going to be 5a, and b is going to be the cubed root of 1, which is just 1. So I bring my 4 down. Remember to bring all your parts down. It's going to be a plus b, so it's going to be 5a plus 1 times, then 5a, the quantity 5a squared, minus 2 times 5a times 1 plus 1 squared. Okay, so this is going to be 4 times 5a plus 1. This, make sure, again, you square the 5. The square goes to the 5 and the a. That's going to be 25a squared minus 10a plus 1. And then that's your final answer. Last one here, I do have a GCF. Okay, the greatest common factor of 24 and 375 is 3. They also both have a C, 1C, and 1D. Okay, that's the greatest number that they have in common. So I divide out by a 3, a C, and a D here, a 3, a C, and a D here. So I end up with 3CD times 8. This is going to be C to the third plus 3 goes into 375. That's going to be 125. These C's divide out. Sorry, those D's divided out. I had 4 D's. Okay, that's actually going to be D to the third. I look at my perfect cubes. Those are perfect cubes. So I know A is going to be the cubed root of 8C cubed, which is 2C. And B is going to be the cubed root of 125D cubed, which is 5D. I bring my greatest common factor down that has to be part of your problem, and I apply the formula. It's going to be 2C plus 5D times the quantity 2C squared minus 2 times 2C times 5D plus the quantity 5D squared. And I remember this last part, so I have 3CD. This is the 2C plus 5D. That part's okay. I remember to square each part, so that's going to be 4C squared minus 20 CD, or 40 CD, sorry, minus 40 CD plus 25D squared. Okay, and I know that's a long one, but it's still not bad because it's just the formula. You just need to make sure that you have it written somewhere and you've used it a few times. Otherwise, you're not going to be able to finish things. So there's just 2 rules. The difference of cubes is basically the same rule, except it's with minus. So you're going to do the same thing. You always find your GCF first. Okay, and you have a cubed minus b cubed. A, of course, is going to be the cubed root of a cubed. B is going to be the cubed root of b cubed. And this formula, it's going to be a minus b. Okay, but it's going to be a squared plus 2ab plus b squared. Okay, so the only difference is that these actually swap with the formulas, and it just has to do with how it started. This is this starts with a minus b because the original problem has an a minus b. It starts with a plus b, then it has an a plus b, and you need to have that minus in there. So the official rule is going to be a minus b times a squared minus 2ab plus b squared. So we do the same thing that we did with the other ones. We find our a and b values. A is going to be the cubed root of x cubed, which is just plain old x, and b is going to be the cubed root of 1, which is just 1. And so we plug that in. It's going to be x minus 1 times x squared plus 2 times x times 1 plus 1 squared. It's going to be x minus 1 times x squared plus 2x plus 1. And that's my final answer there. Next one, no GCF again. A is going to be the cubed root of 216k cubed. B is going to be the cubed root of 125. Again, don't make it a negative. So A in this case is going to be 6k and B is going to be 5. And so it's going to be 6k minus 5 times the quantity, 6k squared minus 2 times 6k times 5, or actually it shouldn't be minus, it should be plus 5 squared. So we have 6k minus 5 times, this is going to be 36k squared. Don't forget to square both parts. Plus 60k plus 25. Okay, just 2 more, just so you kind of have the gist of everything. I go to the next one. Again, always find your greatest common factor first. For this one, I have a greatest common factor of 4. So I divide each part by 4. So I take that 4 out, divide each part. That's going to be 1. Okay, that's going to be 1 minus 8h cubed. Okay, in this case, A is the cubed root of 1, which is 1, and B is the cubed root of 8h cubed, which is 2h, sorry. So I bring my 4 down. I use the formula. It's going to be 1 minus 2h times 1 squared plus 2 times 1 times 2h plus the quantity 2h squared. So for 1 minus 2, I don't know why, 2h, 1 plus 4h plus 4h squared. And that's your final answer. Okay. Very last one. They both have a greatest common factor of 2. Okay, so I bring my 2 out. That's going to be x cubed minus 27y cubed. A is going to be the cubed root of x cubed, which is just x. B is the cubed root of 27y cubed, which is 3y. And so it's going to be 2. And it's going to be x minus 3y times x squared plus 2 times x times 3y plus 3y squared. And so this is just going to be 2 times x minus 3y times x squared plus 6xy plus 9y